So Harry, I'm going to turn it over to you to kick off the roadmap meeting.
Okay, sounds good. So let me share my screen. Oh, could you make me host, Jim?
Oh, sure. Yep.
And sorry, there's like a truck that's outside, so you might hear some noise.
We're good. You're home.
Okay. Okay, so thank you everybody for joining and also contributing to the roadmap document. I read it through and there are a lot of good suggestions. And so the roadmap document that I'm referring to, if you haven't seen it, is this one. And there's a shortcut where you can access it pretty easily. So if you were to type in onnx.ai/roadmap into your browser, then you'll be able to access this document. It's open to public. And basically, a lot of you folks already has inputted their ideas for the next version of the ONNX. And so we are trying to host this roadmap discussion so that we can actually get direct feedback from our contributors and then actually implement the changes that our contributors want. And so we are going to have 6 roadmap discussions. They're hosted weekly. And then by the time when we finish our discussion, we'll probably have a community meeting that's planned for October 14th. But we wanted to kind of divide the roadmap discussions into 3 main parts. I kind of mentioned it in the introduction, but the 3 main parts are basically 1, evolving the ONNX core, and then 2, trying to extend ONNX on a machine learning pipeline. So this is expanding horizontally. And then the last part is basically trying to expand or trying to make ONNX go deeper vertically by getting closer to the hardware. And so those are kind of the 3 main topics. I thought that it'd be nice to start with the second topic, which is basically trying to extend ONNX on the ML pipeline. And so there are 2 specific things that we wanted to discuss for this meeting. And they are basically involving data, how you either ingest it or pre-process it. And then there's also another contribution from folks from IBM who were interested in extending ONNX onto horizontal pipelines such as a Kubeflow. And so those are some of the topics that we'd like to talk about. But if you have any other suggestions, please let us know as well. And please also let us know, because this is our first time hosting a roadmap discussion. We'd like to hear from you whether this is the right way to host this roadmap discussion. And so any feedback would be welcome. And you can either voice your opinion here, or you can also put your thoughts into the roadmap doc, and then we will definitely read it and then make actions accordingly. So any questions before we start? Okay, silence is golden. And so what I have done here is basically I took out some of the suggestions just pertaining to data and machine learning pipeline. And then I put it in under GitHub. If you go to ONNX Steering Committee/roadmap, then you'll find this markdown file. And so you'll be able to see what we are going to discuss today. And then in the coming weeks, we'll also try to put in the markdown files in advance so that you can check out what the discussion topics will be. And so without further ado, we'd like to start with the data portion. And so I can give you a brief summary of what people suggested. I thought that starting with the suggestion that came from Takuya from IBM, I know he's going to actually attend the meeting that's going to be Asia-friendly time, which is coming up next week. But I thought that this was a very relevant topic for us. And so I wanted to put it as a front one. And so there's a lot of there's a suggestion around ONNX supporting data frame. And so his suggestion was that we need to support data frame, and then we can either kind of support data frame as a sequence of tensors or a list of tensors. And then he also wanted to have ONNX to adopt new operators that would be useful for things like pre-processing. And then this was a pre-processing kind of idea was seconded by somebody. It was he mentioned himself as a SNNN. And so I couldn't really.
His name is Chengming. His name is Chengming.
Oh, Chengming. Okay. So that's a GitHub handle, I guess. Great. I did not think about that. So Changming also seconded the opinion on the pre-processing, and then I know Rohit, I think he also entered one line about how he wanted to have ONNX support things like audio spectrogram processing or fast Fourier transformation. And so those are some of the things that were suggested. And then a little bit broader topic is Sheng has been working on the Pi data consortium. And so he also suggested that we need to align with NumPy operator definitions with ONNX. And so that's another related topic. And then now that I think about it, it's not super related to data. Maybe it is, but there's a data layout formats, obviously. And Yuan Kai from Alibaba wanted to have broader support for data layout. So instead of only supporting or kind of de facto supporting NCHW format, we wanted to expand the format so that the format that is being supported better for int8 or float16 data types should be supported in ONNX as well. And then this also will lead into some of the core discussion that we'll probably have in the future, where folks have suggested that we need to have quantized models in the model zoo. And lastly, I wanted to kind of reserve some time, maybe 10 to 15 minutes on the proposal from IBM, from Chin. And I think Svetlana also mentioned this too in the doc, but basically trying to extend the ML pipeline or extend ONNX influence on the ML pipeline. So those are kind of the things that were mentioned. Anything missing that you guys seen that that was related to data and trying to expand it horizontally? If not, then we can start kind of going through these items. Okay. So if you were to think about the data frame support, and Takuya actually gave us a few implementation ways that how we can resolve this, and also supporting the new operators and pre-processing. Pre-processing, we actually had a working group going, but we were actually not able to do this. And so the working group kind of got disbanded without having much of a progress, unfortunately, I think last year. But do you guys think, well, first of all, supporting data frame within ONNX, and then also having the operator expansion, in my opinion, is a good thing to do. And also it will align with the Pi data, greater Pi data kind of a consortium. Wanted to open up to the floor and hear more about what you guys think about it. Maybe Sheng, if you want to give us what you think, that'd be very helpful.
Yeah, sure. So I think I should maybe introduce a bit on the Python Data API Consortium efforts for those who are not familiar with that. So there is a working group on trying to define the future of data API in Python for the purpose of fixing the fragmentation in the frameworks. So right now, lots of the deep learning frameworks as well as the NumPy ecosystems are evolving independently. And lots of the missed opportunity comes from, slightly different definition of array API and lack of interoperability. So the goal of this group is really to build together a data API standard for array and data frame, so that the libraries that each one built could interoperate with each other. So in terms of timeline, I think the array API standard would have a draft pretty soon. The timeline is expected to be September 15th. And most of the API definition is built on top of the blueprint of NumPy. It would be a shared subset of math and operation in NumPy that would come out in the array API standard. So there would be an RFC request for comments process starting from September 15th on this. For data frame, I think it's taking a bit longer. It'll be around November 15th. So there's a bit more work to do there.
I see.
So any question on the Python Data API Consortium efforts?
So in terms of the operators, things that were suggested by Takuya San from IBM, things like MapReduce, group by, those operations are, so I know that we've kind of talked about how we wanted to have the diff in terms of the NumPy operator definitions and ONNX, but with those, because I haven't really looked into all the operator sets that NumPy has, would those actually belong into some of the things that were going to be supported with the new PyData consortium?
So you're talking about aligning the operators, I guess.
Right.
Yeah, so I'm currently working on the diff, and it looks like there are some more grounds to cover in ONNX, so that they can be as expressive as that data API standard. Yeah, so what I'm proposing here is that we should consider as a data exchange format to support and adopt the Python data API standard. That way, whatever model that comes out of frameworks that adopts the standard would be supported in ONNX. So this should be helpful for expanding the the support of ONNX. I
see. Would you recommend then, because the consortium is going to put out the standard for the operators, you said mid-September, and also the data frame around November. Do you think that it would be better to align that time schedule so that we actually align with the greater consortium, and then that'd be easier for users to actually use ONNX? Yeah, I think so. So for these standards, there are still lots of discussions that are happening. And for Array API, I think it would come out earlier. So we should consider maybe taking the Array API standard into account. And for data frame, we can probably wait until the other RFC comes out. I see. Okay. Any thoughts from any other thoughts?
I have a general question for this. It sounds like there is a barrier for ONNX to adopt traditional data structure like data frame. But the underlying mathematical operations are, I guess they are already well defined using current ONNX operators, like min, max, or reduce sum or something. So I'm not sure if we want to extend the ONNX definitions or have like what the author just said, have more better integration with. I'm not sure what is it the Python data API? I'm not sure if it's an API problem or it's a operator and definition problem. So yeah, that's my
So
my thought. Yeah.
Sorry, for the Python data API standard, it's supposed to be a standard that library authors could adopt, so that it guarantees interoperability among all other libraries that adopt the same standard. So in terms of, can you hear me?
Yes.
Okay. So yeah, so for ONNX, I think given that other libraries are adopting this, I think by adopting the same standard, it will make model exchange with ONNX on such libraries very easy. So that's the motivation. In terms of approach, I think for Array API, lots of the operations are already quite low level. So instead of using the current operator standard, instead of using the current ONNX operator set to try to build for those operations, I think we should just introduce them as pretty primitive operations.
I see. Any other thoughts? So this is this session is, since it's just the first one, we're not going to try to make a decision here. Basically, we want to hear the ideas, and then we would like to think about it, and then maybe in the following session for that particular kind of 3 main areas, we can kind of have some closure in the second meeting. So
is there any spec for this Python data API? Because it's a little bit vague, right? Like, can we read this up somewhere?
There is, I think, if I'm not mistaken, I've seen it. I think it should be readily available. If I'm not mistaken, Sheng, is that correct?
It's not available for public yet.
Oh, I
so
see.
Yeah, the RFC
I've only
will be
seen
posted.
the screen share, I guess.
Okay.
So
yeah. I don't think I mean, lots of it are still work in progress, so I don't have something that's ready to share. I pasted a link in the chat on the blog for this consortium. So the RFC for Array API standard is due to come out in about 2 weeks, and we can at that time we will be able to see what are the definition for the APIs.
Yeah, I think we would need to wait until we actually can read over this, right? Like, how else could we decide anything?
I agree. Yep. But it's good to have that thought in the back pocket when we think about whether to enable data frame or have new operators to support for these. So, okay. So go ahead.
We watch out for it
Yes.
when it comes out.
Yeah. So we only have 10 minutes left, or 11 minutes left, and so let's move on to the next topic. This data layout format. Any thoughts on this? Or we can park the discussion until we actually talk about ONNX core, where we can actually talk about also kind of supporting the quantization models on the model zoo. And that could be another good discussion topic there. Okay. If not, we can talk about this collectively with quantization, I think. So Chen, we have about 10 minutes left. Could you kind of let us know what your thinking here is for implementing ONNX for within Kubeflow? Could you give us some detail as to what you're thinking about?
Sure. The first thing is the concept of a pipeline, right? In ML world, it means to have a workflow that includes all components, right, to work together and to make sure the end-to-end ML development can be organized and orchestrated, right? I mean, so a pipeline in Kubeflow in particular includes 2 parts. One is the content, like the model, the data, and the second part is the infrastructure. So Kubeflow combines these 2 together so that the end user can work on their application, their model, and their issues, and not having to worry about too much about the underlying infrastructure, distribution, cloud, and so on. Right. So I'm trying to see how we can bring ONNX into this Kubeflow pipelines, so that the end users can start leveraging ONNX in a broader context. We know ONNX is a good standard to specify models and so on. but the goal here is to see how we can, make it easier to be consumed, especially if they're like users using Kubernetes as their infrastructure and environment using Kubeflow already. Can they leverage ONNX? So that's sort of the goal of this, idea.
I see. Do you have any specific suggestions? The way that I can think about this, maybe having like a easy to access API to take models from Model Zoo and then have it run.
So let me maybe quickly show you what I have, right now. If
Okay,
I can
let me unshare then. Give me 1 second.
Yeah, it's like one quick chart. So people will understand the idea. What is a pipeline in Kubeflow, and what we might have if we introduce ONNX into that space.
Okay, I'm trying to make you a host. I don't think that I have the.
Oh, I think probably Jim has to do it.
Okay, I see.
That's okay. So I can talk about that quickly. So right now I have seen one in Kubeflow that works for MNIST. Basically, it has like 3 steps, right? From the hyperparameter tuning to training to inference. Basically, very simple 3 steps.
Mm-hmm.
Of course, if
by
ONNX,
the way, you're the host right now, so you can share now.
Oh, sure. Okay. So let me just share this one. You see my chart now?
Yes.
Yeah. So essentially, this is the example in Kubeflow to get MNIST, right, from tuning to training to model deploy. So I put ONNX here just to see whether we can go end to end using ONNX. Because of course, right now Kubeflow is using TensorFlow, okay, as their example. I know PyTorch is working into Kubeflow as well. When I say working into is to build certain constructs and components so that, for instance, training can be distributed in Kubernetes clusters. Okay, so as we all know, ONNX model can describe the inference. So the last part here is no-brainer. And once we have training all described in ONNX, we have ONNX runtime or some kind of backends supports ONNX training, we can achieve this one as well, right? So similarly for the hyperparameter tuning, we can use combination of training and inference. So I think we can do this eventually, okay? The last one I want to show is with a more comprehensive or complex scenario. Here you see a data processing here, right? Can we describe that? Right now we cannot. That means ONNX model is not going to work right now. But this is a common use case, right? You have some issue in data, you want to go through some machine learning process to make sense of it. And then we go through pre-processing, transformation, a few steps. So what I'm trying to see is if we can build a few Kubeflow components to do, for instance, like I said, distributed training, right? To leverage the power of Kubernetes. At the same time, I want to see whether we can cover more steps here rather than we only do the inference part. It makes sense? So as far as what specifically we need to develop, I have some ideas. One is that if we go back to the MNIST example here, the model training is done by a component called TF job. So essentially, it takes the training jobs and spin off like a master and a few worker nodes. So the training can be distributed. So similarly, we can have an ONNX job, right? Then we can leverage ONNX runtime to do distributed training. So that's just one idea, right? So as far as how we want to see the angle, I would like to see whether at someday we can have very clear path from the issue, from the data. You use ONNX as early as possible, rather than you do a lot of things in a framework and only convert to ONNX for inference, right? So that's the idea behind this proposal here. Any questions or comments on this?
So in this case, what you're suggesting is we expand Kubeflow to have ONNX job to enable distributed training. And the next slide is, if you were to expand even beyond that, you need data processing and then transformation to tie up to the to get to the model training part. Is that what you're saying? Okay.
Right. Without anything right now, we can do the last part. We can somehow convert to ONNX model and deploy to a KF serving. ONNX has a runtime there already, I believe. So that's what we can already do right now.
Yeah. One quick question.
Sure.
What is our progress with ONNX model training right now?
Wei-Jing, can you make it? Yeah. I know people are working hard on that. We have a a preview version of that.
Yeah, ONNX runtime itself supports training transformer models from PyTorch today.
Okay, yeah.
Did you say transfer learning or what was it? Sorry.
Transformer models like BERT, GPT-2, things like that.
Right. I see. Okay, so I think here there are two things, I guess, in terms of when you look at this. There are data processing parts that a lot of people mentioned before, which is slide 5, and then slide 4, basically strengthening the training part, and then also having it implemented under Kubeflow. Would that be the correct summarization?
Yeah, I think so. Of course, the assumption is that ONNX supports training.
Right.
Then we can do the distributed training, right?
Yeah, I guess a lot of things are relate to the details like pre-processing and transformation. What would be interesting is what types do you want? Are you interested in, and what kind of transformations?
Okay, this depends on the issue domain, but this is a very common process. You have text, you have some raw data. You want to make sense of it. So the first step you do is to do the data processing and the transformation. Sometimes you want to bake that into your model as well, so that when you do inference, again, you can take the raw data in, right? Without pre-processing outside of the model.
Right.
Make sense?
Right.
Yeah.
Would it make sense to start with, so we have the models in the model zoo, and we now have a lot of models on NLP as well. And so maybe starting with the models that we had in model zoo, and see how the data needs to be pre-processed and transformed for the models that are on the zoo, and then that might be a good starting point if you were to think about pre-processing.
Right. But again, this is not purely inside of the ONNX core project. As you can see, this is going above and beyond, right? Trying to make use of the standard in a broader scope.
Right.
I have a question. Does Kubeflow define operations like data transformation and data processing, or it uses other standards to do it?
Kubeflow does not. Kubeflow is much higher level. It allows you to define your own component. So for instance, each box here is a component. It's a combination of software and usually is a Docker image. because like I said earlier, it's more about deployment distribution.
Okay.
Yeah.
I see. Okay. I noted your proposal in the roadmap document, but if you could send me this slides, I can also link it to the roadmap document as well. But this was this was a very interesting proposal. Thanks for putting this together.
Yeah, no problem.
Okay. So we're a little bit over, but I think in the subsequent meetings, I think that we will be able to assess the impact, and then we'll try to also have a bit more closure on the what we want to implement, at least horizontally. And so thank you so much for participating, and then please look for the next discussion. We'll have 5 more coming up. So yeah. Any last questions or comments before we move on? Okay, please let us know if you have any feedback. We will definitely take it. You can put it on the roadmap, or you can also kind of submit as a PR on the steering committee. So thank you so much.
Thank you.
Thanks. Bye-bye.
Have a great long weekend. Bye-bye.
Bye-bye.